Hello, good day viewers. So in today's video, we are continuing with our previous lesson that we started on integration. So in our previous lesson, we learned that integration is the reverse of differentiation. And we said that integration, we have two approaches to integrate. We have what we call a definite integral and then the indefinite integral. We say a definite integral are those functions that have what? A limit. And indefinite integral are those without what? A limit. So we clarify that with an example and then explain the whole issue. So if you haven't watched that video, I've given the link in the description section of this video. Please do well to go through before you proceed to this video. So in today's video, as I said in our previous video, we want to actually support today's video in our previous video with what? An example with an indefinite integral considering what? Fractional issues as a function. So this is our example that we are asked to deal with. Integrate the function below. So we have what? The integral symbol 3x cubed plus 2x squared minus 5 all divided by what? X squared dx. So we are asked to integrate this function. So now, to integrate this function, the first approach you want to use is first of all, simplify the expression or the function here in its simplest word form. By that way, you reduce it to its simplest word form. So remember, we can also write this same function here as with my integral symbol. So that's going to what? Can I write this as what? 3x cubed over what? S squared plus 2x squared over s squared minus 5 over what? S squared. I can rewrite this function above in this form. I haven't done anything new. It's the same function that you see here. Good. So if that is the case, then we can apply our laws of indices to actually simplify this expression in its simplest so that we can easily integrate the function. So in this way, our laws of indices tell us that if I have equal exponents, right, and I'm dividing, I'll subtract what? The numerator exponent from the, I'll subtract the denominator exponent, sorry, from the numerator what? Exponent. So this is what I would do. I will say that I have 3x cubed minus what? 2. Because we want to reduce it to its simplest form. Plus 2x squared minus what? 2. So realize that we subtract the denominator exponent from the numerator exponent minus 5. Remember, the 5 here can be written as what? 5x to the power of 0, which is the same thing as what? A number to the power of what? 0 is the same thing as what? 1, the extension of what? Negative. So I can write this as what? 5x to the power of 0 and then subtract 2 from what? The 0. That becomes what? Minus what? 2. Okay? Remember, we're still in the realm of what? The integration. So you have your integral symbol repeated and put them in bracket. Should I bring it a bit down? So the x. So we have a integral symbol, which is, so here going to give me what? 3x, right? Plus, here's going to give me 2x to the power of what? 0. Here's going to give me minus 5x to the power of what? Negative 2 dx. So once we're able to simplify it in its simplest form or reduce it to its simplest form, now we can move along to integrate this function. So let me bring it a bit up here so that you can see. So let me have a space created for this. So I'll have this once again repeated as what? My integral symbol or sign, which is equal to 3x plus 2x to the power of 0 should be 2 minus 5x to the power of what? Negative 2 dx. So now we can integrate this function. So by integration, I'll add 1 to the exponent x and then divide the result by that. So I think by right now, you should be able to know how to integrate, or at this point, you should be able to know how to integrate the function. So we're not going to go by the addition and subtraction. So once we know that, we can straight away move to integrate. So here it becomes what? 3x 1 plus 1, because x here have a power of what? 1. So I'll divide the result. 1 plus 1 is what? 2. So I have 2 here, repeated. Plus, remember, I can write this as what? 2x to the power of 0, right? And if I want to integrate, I'll add 1 to the 0, so plus 1. And then divide the result. So 0 plus 1 is same thing as what? 1. And I'll do same with the negative 5x to the power of negative 2. So that's going to give me negative 5 x to the power of negative 2, and I'll add 1 to the negative 2, and then divide the result. Remember, negative 2 plus 1 should fetch me negative what? 1. I hope that is okay. So at this point, I can see that therefore, and since it's an indefinite integral, you introduce a constant plus say k. Okay? So in its simplest form, we can therefore say that we have 3x to the power of 2 divided by 2, okay? Plus, remember, here it can also be written as 2x. A number out of 1 is same thing as what? That particular number, okay? Minus. So here too, I can write, remember here is what? Negative 1. So negative 1 will cancel the negative here, making it positive. I can have it to be plus 5 x to the power of what? Negative 1. But remember, here is negative 2 plus 1 should fetch me negative what? 1 plus what? K. So therefore, we can say that we have 3 over 2 x squared, okay, plus 2x plus 5. Remember, I can rewrite this as what? 5 over what? X plus k. If we were to be 2 over x, we write this as what? 2 to the power of what? 2x to the power of negative 1 in a linear form. But if I want to write in a fractional form, it becomes for 2 over x as you see here. Okay? If we were to be 3x to the power of negative 2, I want to write this in a fractional form, it becomes what? 3 over what? X squared. If I want to write it in a linear form, it becomes this, as you see here. So that's what we're actually talking about. That's why we're having 5x to the power of negative 1 can be written as what? 5 over what? X. So this is how we integrate a function where we have fractional approach, or a question where we have fractional approach in it. All that you need to do is to reduce it to its simplest form. Once you reduce it, then you go along to integrate the function. So thank you for watching this video. If it was really helpful to you, please do well to like this video, subscribe to the channel, and share. So I'll see you in the next video where we discuss definite integral. Bye bye.